In this module, we'll once again lay out some space nodes for our guest room modules. However, this time we're going to lay them out along the curved side of the building. So we're going to do this a little bit differently. But again, I'll start with a space node. So I'll take the space node, drag and drop it onto my graph, and I'm going to call this space GR South. And again, I will use a point grid. However, I'm going to generate this point grid differently. Go ahead and select our space type again. I'll do residential. And then again, I'll put a point node on the graph. I'm going to call this point GR South. So for this point grid, I don't have a surface because we didn't create our floor plate as a surface. It's a closed shape. I do, however, have those two arcs. So I'm going to take a look at my techniques. We have a technique which is by number of bays along a curve. So let's select that. So I want to basically create points along those two arcs. So the arcs will be my curve. So I'm going to link that back up to my arc GR South 01, and I'll link GR South 02 to that as well. Then I need the number of equally spaced bays. Well, we've already got that expression for the number of guest room modules, so I'm going to link to that. There's a couple of other properties this node needs. One is a start bay fraction, so I could actually create a fraction of a bay at the beginning and the end of my arc. So for instance, if I wanted to leave room for some stairs, maybe half a module, I could put a 0.5 value in there and it would leave that half a module. But I'm just going to put 0 in here for now. It's a little more detail than we need at this point. And now you can see I've got my point grid along the arc. It radiates towards the center of those arcs. And since I've got the point grid, I can then link that back to my spaces, and that will generate the space shapes. Interesting little problem here. You'll see it generated our spaces on the face of the arcs rather than on the horizontal plane where we want them. Now this has to do with the way it reads the list information from the point grid. So if we look at one of those points, you'll notice the indexing on the point, there's actually 3 values because we had the 2 curves, and each of those curves was a list, so we had multiple curves. And so we have what we call a nested list here, and that's what's generating the point grid. So the order of that nesting affects how it actually creates those spaces. So there's a function in GC which is called transpose. So I'm just going to start typing that in. So transpose simply means to swap or to reverse. And we'll put the rest of the expression in parentheses. So it's going to take those indexing values and basically swap them or change the order, and you can see now our spaces are laying flat on the horizontal plane. We've got 7 spaces per arc, and they have an area of 344, which is close to our target area of 350. I'm going to go ahead and record those transactions. And again, I'm going to open up the Data Group Explorer, look at our space hotel room module schedule. So you can see now, I've got 42 spaces at 357 square feet. These are the linear spaces on the back of the building. And I've got 35 at 345 square feet. I'm also going to go to that space node and defer the update on that one as well. And we'll record that. Then I'm going to open the control panel and make some adjustments to the model here. So for instance, I might want to increase the depth of the arc. Increase the depth of the guest room module, which should change the number of modules we get per floor. And perhaps I even change my target area. So maybe rather than 350, we want to shoot for 315. Let's go ahead and update. And I still need to do the update model since I deferred the update on the spaces. And if I refresh the Data Group Explorer, I can see the effect that that has on my count. So now I'm getting 30 modules at 312 feet, another 30 at 313, and then 50 at 294. So I can immediately see the effect by changing those parameters would have on the actual number of modules in the stacking model.